Hi. A lot of the times in our lives, we do comparisons of quantities, be it length, weight, age, anything like that. So let's take an example of a daughter's age being 10 and father's age 40. So, looking at 10 and 40, we certainly know that the daughter's age is less and the father's age is more. Now, the question is how much more is the father's age compared to daughter's, right? So, such a question can be answered or communicated using a math concept called ratio. Let's see what materials we have today and how we can use that for ratio. Now, we have something called as Cuisine rods. We have rods of all different sizes. They are color coded, but we could distinguish them using size as well, the length as well. So the unit one is a cube. The smallest one is like a cube, and the two cubes make two. So I'll just line it up here. Two cubes make uh, the second rod, which is of two. Then the three cubes make three here, the third rod. So then I have fourth rod, which is one cube bigger than the third, and then fifth, and then sixth, and then seventh, eighth, ninth, and tenth. I just lined up like a staircase. So I know the difference between all of them, and I certainly know that the difference is just one unit between any two consecutive rods. Um, Now I have a box with many rods, all bifurcated, and I'm familiar with what is where. Now this is color coded also for sighted children, but you can easily make out with size. Now over a period of time, when the child is familiar, the child can make out by touch what it is. Okay, we don't have to really write the color on it, but it definitely requires familiarization. So this is a drawing board that I'm using where I'm keeping these rods in so that I have a boundary. So it's easy for me to define what they are and I know where exactly I've kept. Now, if I have to go back to the problem of communicating the daughter's age and the father's age and the comparison between the two, then I would say take the daughter's age to be one unit, which is 10 years, right? And then I know that father's age is 40. So one, two, three, four. I will take a four, uh, which is 40, right? So I know that there are four units which make up the four rod four. So it is same as having one long rod of four. So now the comparison is that if the daughter's age is 10, the father's age is 40. So if the daughter's age is 1 cube, the father's age is one big rod. So this is how you compare. Now when you touch it, you know the difference. You know how big, how much more is father's age compared to the daughter's age. Now this is communicated in math as 1 is to 4. Daughter's age is to father's age is 1 is to 4. The other way around also can be communicated. Father's age is to daughter's age is 4 is to 1. So both ways are correct. Okay, I'm putting this back. Now that you know what ratio is, now if we say there's a ratio which is where I cook rice and then I add for every glass of rice I add 2 glasses of water. right? So that means for 1 glass of rice, I add 2 glasses of water. So I have 1 cube, which signifies 1 glass of rice, and then 2 cubes signify is telling me that these are 2 glasses of water. Now I'm putting this two back and exchanging it with the two rod. So that's how I know it's 1:2. So when I touch, I know that it is which is bigger, water is more or rice is more. By how much? You know? So that is 1:2. Suppose I take a ratio of 4:12. So I take a 4 rod, and then I don't have a 12 rod, so I take a 10 rod and a 2 rod together. Okay. So I have 4:12. Now, if I again have to compare, 4:12 is good enough. But if we want to simplify, then I would see how many of these fours would make the 12, if at all they do. So I am taking 4 rods and then lining it up against 12. And I see that there are 3 rods that line up exactly the same length as 12. So I'm going to remove this 12 and keep the 3 4 rods. Now that all of 4 rods that I have, so the first 4 rods is of 4, and then the second 4 rod is the 12. Second one, which has rods of 4, tells me that it is 12. So I have 1:3 4 rods. Now 4:12 is same as 1:3. So that is nothing but simplifying the ratios. If I take another example, 8:12 or 12:8, then let's see how to simplify that. Okay, so I'm going to take 12, so 10 and 2, and then 8, right? So this is 8, so I have 10 and 2 as 12, and then the rod 8. Now, the first thing that I will do is I will check if I can put the rods of 8 to make 12. It's much, the 2 rods of 8 actually goes beyond 12, so I can't use that. So now comes my knowledge of factors into place. Now, I'll have to see the factors of 8 and 12, which is 2 and 4, which are 2 and 4. So I will just take 4 for now. And okay, let me take 2 first, and then let me see. So if I take 2, then uh, I'll have to take many 2's to make 12. Now I'll see how many 2's I need to make 12. I'm just lining it up against the 12 rod, and I see that there are 6 2's that make up 12. So I'm going to remove 12 um, now that I made 12 using 2 rods. I'm going to remove it, and then I'm going to start making 8 with 2's, lining up 2's against 8. So I know 4 2's make 8. So I'm removing the 8 rod and keeping it back. Now I have all rods in 2. So I have 2 rows. The one for the first row has 1 2 3 4 5 6 rods of 2's, and the second row has 1 2 3 4. 6:4, right? 12:8 has become 6:4. Right. What I can also do is, now I'm going to take 2 separately and replace it with the 2's, the fours. 2 plus 2 become 4, right? So I'm going to replace it with the 4s. So I'm lining the same 12 line with the 4s this time. So I'm keeping 3 4s and then removing all the 2's that make up 12. And then I'm doing the same thing with the 8 also. There are 4 4s. So I'm taking out 2 and then replacing with a 4 rod, and then 2 again and replacing with a 4 rod. Now the same ratio now is in all 4s. There are 3 4s that make up 12 and the 2 4s that make up 8. So this is 3 is to 2. Okay, that's a simplified version of 12 is to 8. Thank you.